In this lesson, we will look at Unit 2, Section 2.7, Solving Problems Involving More Than One Right Triangle. In this lesson, you will learn how to use trigonometry to solve problems modeled by more than one right triangle. First, we're going to look at a new term, which is the angle of depression. Angle of depression is the angle between the horizontal and the line of sight to an object beneath the horizontal. The complement of the angle of depression will be used to help find the unknown measure in a right triangle. So as you can see here from the diagram on the bottom with the person standing up and looking at the car, the horizontal would be his direct sight straight across, but the angle of depression would be formed by the horizontal and his line of sight to the car. If you look at the question above that in the example of the triangle, we have an angle of depression of 38 degrees. And let's say for an example that we want to find just the angle TPL. So we want to find the other side of P. So we would have to look at that. If we ignore the line P to L, we can see that that would be a 90-degree angle. So in order to find the angle TPL, you would have to go 90 degrees subtract 38. And this will give you the complement to find the other side of our angle. So 90 subtract 30 will give us 52 degrees. Solving problems involving one or more triangles. We can use the trigonometry to solve problems that can be modeled using right triangles. When more than one right triangle is involved, we have to decide which triangle to start with first. So if you're given a question where there's two triangles joined together or there's several, the first step is always to determine where do we start, which triangle do we look at first. To do this, you will need to decide which triangle is given the most information. Of course, you can't start off with a triangle that is only given one piece of information. It needs to have two or more things given and known in order to proceed. A combination of the trigonometric ratios and a Pythagorean theorem is going to be used in these questions. A strategy for solving the problem must be developed before a solution is attempted. So before you can actually say how am I going to solve and go into the question, a strategy to how to set it up and how to proceed with the solution must be developed first. So we consider the following example here. We have two triangles joined together. We have triangle ACD and triangle BCD. We have the angle C given and side AD given in the first triangle. In the second triangle, we only have BD given. So to calculate the length of C to B, more than one triangle will be used. A decision must be made about which triangle to start with. So if you look at triangle ACD, we know that there is an angle given there and a side, so that must be used before looking at triangle BCD, since we have more information known for ACD and there's very, very little known for BCD. And sometimes when we look at a question where there are two triangles joined together, it is a great idea to first begin by finding the measure of the side that is shared between the two triangles. So if we look at our question here, C to D is a shared side, so it would be a great idea to find that first. Then you would give a little more information for triangle BCD as well as ACD. When solving a three-dimensional problem, it is important to visualize the right triangles within the diagram. The right triangles can be redrawn in a two-dimensional shape, where the appropriate trigonometric ratios or the Pythagorean theorem can be applied. So as you can see in the diagram here, we have a rectangular prism where inside we have a right triangle. So if you're looking at that whole shape as one three-dimensional problem, it could be a little harder to pick apart and decide what the length of the hypotenuse would be. But if we take out that triangle and just take it and sketch it on the side and make it a two-dimensional shape, we can see then that we have the legs, both are 5 centimeters, and we have to find the hypotenuse of x. So the value of x can be determined using the Pythagorean theorem, since that's a question that was applied back in grade 9, where you just have to use your L squared plus L squared equals your H squared. And if you want to extend the question where we have to find the angle of theta, then the tangent ratio can be applied to find that theta. Since we are already given the opposite and the adjacent sides, then the tangent ratio can be applied here. So as you can see, by picking it apart, the three-dimensional question, and making it into a two-dimensional shape, you can see how the Pythagorean theorem and a trig ratio can be applied here. So in summary, when solving problems involving more than one right triangle, first develop a strategy that can be applied to solve the triangle. The trigonometric ratios to one triangle at a time, or the Pythagorean theorem can be applied. So apply the trigonometric ratios one triangle at a time, and then the Pythagorean theorem could also be applied to find a third side. Use the definition of the tangent, sine, or cosine ratios to create an equation. You can then solve this equation to determine the measure of a missing angle or the missing side length.